Covalent bonding is a type of bonding that is present in nonmetals. So when two nonmetals combine, they share one or more pairs of electrons, forming a covalent bond. So for covalent bond, only the outer shell electrons are drawn. So for chlorine, in its outermost energy level, it has 7 electrons. Another chlorine in its outermost energy level will have 7 electrons. So a bond is formed by sharing these two electrons here, so that the one chlorine is full and the other chlorine is full also. For hydrogen, each hydrogen has 1 electron in its outermost energy level. So a covalent bond is formed where the 2 electrons are shared by the 2 hydrogen atoms. Methane is another one. So when you bond 4 hydrogen atoms with 1 carbon, you form methane. And in methane, each hydrogen comes with an X. It is given a dot. Carbon has 4 electrons, and therefore the whole of it has 8. It becomes stable, while hydrogens only needs 2 electrons to become stable. Hydrogen chloride, 1 hydrogen and 1 chlorine with electron configuration of 2.8.7. So hydrogen chloride molecule is formed whereby one of the electron is donated by hydrogen. So it is given an X, chlorine gives a dot, forming hydrogen chloride molecules. In some cases, electrons around the central atom may not have normal gas configuration. For example, in boron trifluoride molecule, the bond is formed by joining 3 fluorine molecules to 1 boron, forming a boron trifluoride molecule. So the boron trifluoride molecule, you can see that boron has only 6 electrons. It does not have the 8 electrons as the other molecules normally have. Phosphorus 5 chloride, that is PCl5, it is formed by joining 5 chlorine molecules to a phosphorus. Chlorine has 7 electrons in its outermost energy level, while phosphorus has 5 electrons in its outermost energy level. So each of the phosphorus electron is bonded to a chlorine, making it have a stable electron configuration. So that is PCl5. And then you have tetrachloromethane, where we bond 4 chlorine molecules and 1 carbon. Carbon having 4 electrons in its outermost energy level, and chlorine having 7 electrons in its outermost energy level. So each of the X in carbon is shared between the chlorine, where the chlorine brings a dot, forming tetrachloromethane. Barium chloride, you have 2 chlorine atoms and 1 beryllium, forming BeCl4. Multiple covalent bonds. So double covalent bonds, they are represented by two bonds. For example, in oxygen, we have 1 oxygen with 6 electrons in its outermost energy level, and another one with 6 electrons in its outermost energy level, and therefore there are 2 covalent bonds between the 2 oxygen molecules, forming O double bond O. In carbon 4 oxide, you have 2 oxygen molecule with electron configuration of 2.6 and 1 carbon with 2.4. So carbon has 4 electrons and oxygen has 6 electrons. So there is formation of 2 covalent bonds between oxygen and carbon on either side of carbon.